Perfect. Cool. You're all set.
All right. Well, thanks for having me, y'all. My name is Cole Kennedy. I am the CEO of TestifySec, and today I'm going to be talking about keyless signing and verification of artifact metadata with a new project that we recently made public, Witness, and then, of course, our favorite tool for certificate issuance would be SPIRE. Again, my name is Cole Kennedy. I have a provisional. I'm an named author on a provisional patent for zero trust architecture. Actually, with using SPIRE for Duke Energy. I've worked with Citibank, U.S. Air Force Platform One, Keysight Technology. I am a co-author of the CNCF Secure Software Factory paper, and then my CTO, he's with me too, Mikhail Swift. He authored the Untitled PKA policy integration, the ITE7. He worked with me at Joint Special Operations Command and then led a DevOps team for U.S. Air Force Platform One. So quick overview of what Witness is. It is a pluggable framework for supply chain security, right? We really wanted to find something that was really broke down the problem into, easily extendable components. And we wanted to collect information about what happened, where it happened, how it happened, who did it during a CI process or any server process that produces an artifact or information that goes into the decision where an artifact can be executed. We wanted to make it easily extendable, and we wanted to use open source standards and specs for interoperability with other projects. So there's this attestation based security model that, Six-Door is talking about, and we really want to implement. But I think, the SPIFFE SPIRE project was really the original foundation of some of the concepts around attestation. So we really want to plug on those. And what we want to do is generate secured selectors during an event that we can use later down to evaluate against organizational policy, right? So, example policy is that, hey, we want to make sure that this artifact actually gets built on infrastructure that we own, that is where we expect it to be, right? If you're the US government, you might want those artifacts are going into mission command systems built on, AWS GovCloud. We want to make sure that those artifacts don't contain dependencies of Log4j or any of these other CVEs that are so horrible. We might want to make sure that artifact passed SAST testing, and then we also might want to check that that artifact it contains only code signed by individuals that we trust, right? So this is what we do with Witness, right? Every single point along the CI process, we collect attestations, right? We normalize data and we sign that data and we store it in a transparency log. We use Recore for that transparency log in our first design. Now that evidence can then be evaluated anywhere. This effectively decouples a policy enforcement point from the CI pipeline. In traditional CI architecture right now, the policy enforcement point is almost always inside that CI pipeline. If you want to make sure that artifact was built on infrastructure you owned, right, that policy enforcement point generally has to be in that CI pipeline. With Witness, we can remove that restriction and generate whatever selectors we want and evaluate them wherever we want. All right, so this is the basic architecture of the attestation process for Witness. So we have these different we have this life cycle for attesters. We have free attesters that generally collects information about the environment. Currently, we have attesters for JWTs, for Git repos, for Maven packages. Then the next attester that we have is called a material tester. Now that takes all the materials that in your current working directory and calculates the secure the SHA-sums of them and stores them in an attestation. And then in the middle there, you see we have a command run attester. That actually wraps whatever command you tell Witness to run, right? Witness wraps that command and then inspects what happens during the execution of that command. We have an alpha feature that actually does tracing of that command. So we actually get fine-grained detail of all the materials that go into that compiler process, as well as all the hashes of the processes that touch those materials as well, right? Because we spawn sub processes or we may, like in the case of a tool like KO, right? We really don't know which version of Go is building that binary, right? So now we actually, because we're capturing all those intermediate steps and all those sub processes, we can actually get that hash there. Then we have a product tester, right? Anything that is the output of that command run a tester is a product. We calculate the hash and then the MIME type of those products. And then the post testers, these are kind of cool because they actually take those products and allow you to generate additional selectors. So for example, when you build a container image and you output that container image to a tar file, we want to inspect that tar file to pull out things like the container IDs in the individual layer SHA-SUMs as well, right? So we can use those as secure selectors later on and maybe an admission controller. So we take all those attestations and glob them all together in what we call an attestation collection. And those are assigned together by a key provider. In this talk, right, we're talking about SPIFFE SPIRE. So SPIFFE SPIRE is the first key provider that we provided integrations with. And then once they're signed, they get pushed to a store. Our first integration for the store is Record. And then we have the verification process, right? So when we want to verify, if all we have is that artifact and we want to verify the provenance of that artifact, right? So we query that artifact by the SHA-SUM of it, and we get all these attestation collections, right? We build the graph, the dependency graph of everything that took to make that artifact. We put all of that together and we evaluate that against a policy that we create and then actually sign to make it a final determination whether that artifact meets policy or whether that needs to be rejected. So we've actually had to do a lot of work to actually get keyless signing to work with Witness. The first thing we needed to do is we needed to extend the DSSE specification to include intermediate certificates. DSSE currently, if you look on the right, see that intermediates, that's not part of the specification, but we need that there to actually do the trust bundle verification of these attestations. The other thing we need to do is instead of using the time that these artifacts were actually signed, excuse me, let me back up. Instead of using the certificate expiration time, we're actually using the integrated time with Recore, right? That allows us to use short-lived certificates that last just long enough for that CI process to execute. And we don't have to worry about key loss, or we mitigate against key loss. And then also we added in total ITE7 support. Previously we contributed that to Intoto, and we've included that in Witness, and that allows us to provide specific constraints against these different attestations. So we can determine exactly what function areas are allowed to execute these steps. It allows us to do some fun things too, as far as like proving reproducibility over different domains. For general architecture, this is what it looks like. I shared the link to this slide deck in the comments, so feel free to take a look at this. But we are using SPIRE as our main key provider, and then using GCP to back SPIRE. And so what happens here is that the job is executed on a runner that actually has SPIRE agent running. We talk over the UDS socket, and that runner is issued a SFED. That SFED is used to directly sign those attestations that Witness creates, right? Those are stored in Recore, which stores them in Trillium log server, which we can replicate with all of our friends to ensure that that provenance is accurate and can be trusted. All right, so let's go ahead and actually do a demo. So what we have here is a GitLab repo, and I'll open up this GitLab YAML first. You can see all we needed to do to integrate Witness with GitLab was add this line right here, right? So we're doing Witness run, we're saying what step it is, and then we're saying, hey, we want to actually output the attestation to a file, that's optional. And then we're wrapping this command, right? Go build hello world main.go. And then we have these two steps here. We're going to verify it. First, we're going to verify it using a Recore server. So we actually have a public Recore instance with the DSSE extended specification that we have running right here. Y'all are free to use it. And we're going to create this server for that attestation. And also you can use flat files for this as well. Some of the trust breaks down with the time stamping and stuff. We got a little bit of work to do on that using flat files, but it still works. You can verify using just a file, and there's no actual hard dependency on Recore or Aspire or any of this stuff. It's all modular and can be swapped out. So when I go to pipelines, all right, so let's go look at the failed pipeline first. So the first thing we're going to look at is actually the Stalker file.builder. Right, so this is our builder image. We're taking a recent version of Go, and we're grabbing a bunch of different tools that we use during our CI process. Ideally, these would be in separate containers. And then what we're doing is we are so I don't know where that file went, but once you build the container, you actually do the SPIRE registration. And of course, that file is gone because of the demo gods. But the registration already does exist, so that's fine. So then the next thing you need to do is actually create a policy. So I have a policy template here. So what we're looking for is we want these different types of attestations. We want a material attestation. We want a product attestation. We want to make sure there's a command run attestation. And then we have these two, right? We have a GitLab attestation and we have a GCP attestation. But what you see right here, this is a little template that's going to get filled in. We have a little Rego module that's base64 encoded here for GitLab and GCP IIT. So let's go look at what those look at. So let's look at the GCP Rego. So what we're going to do is we're actually going to check that the project ID that this was compiled on equals the project ID that we expected to. The cluster location that it's built on actually is the cluster location. And then we're also going to make sure that the claims on the JWT actually came from Google and is not forged by another party. And then look at the GitLab. Right, kind of doing the same here. So we want to make sure that the pipeline definition that we're using to build this is actually the one we expect, right? That's our organizational policy. We're also checking the JWT claims. Now, there's a whole slew of selectors that are actually on these attestations that you can select from. I mean, you know, and the AWS, it's all the AWS metadata that build happened on, right? So we're even talking about like that base image where all that happened. It gives you a lot of ability to go back and look at things if you do have a security incident. So then I have this little template policy, right? So we're just gonna go ahead and use SED and some YQ and some other stuff. And then finally, we're gonna take that policy that we templated out and sign it with some keys that we generate right here. Ideally, you'd sign these with a hardware token, but we're just gonna cheat for the demo here. So let's go ahead and actually template that policy. All right. We go witness. We'll actually verify that artifact. I downloaded that from that GitLab repo. Look at that, it works. So let's actually change that policy. And let's pretend that our policy says everything needs to get done. Actually, right, so this should fail. So first, let's retemplate that policy. We're going to make a new policy here. So we're signing a new policy, and then we'll go use that to do the verification. Right. So because we expected a project ID of foo, but this artifact was actually built on our infrastructure on GCP, right? We're not going to allow that to go into our system. So now if we look at what actually happened during our pipeline, if I can get to the right screen, right, we can see right here. Right. Policy was denied due to foo.com. Now, what's great is Witness, we really designed it as a library with the command line interface front end. So, we have a prototype and mission controller that includes this functionality, and it's built right into the CLI tool itself. So we've essentially allowed you to create attestations and secured selectors anywhere during the build process that you want, and then use those secured selectors to make policy decisions, whether those artifacts should be allowed into your execution system or not. All right, and then what are all your questions? I'm sure you have a lot.
Any questions?
Have you tried it with Tecton?
I mean, this is just in total providence, and so it should work, right? I think we're probably going to run into a few things, but there's no reason why we shouldn't be able to verify Tecton chains if there's a schema for that. And if there's a schema for that providence object, right, we can actually create OPA policy against that as well.
Cool.
What other questions? Again, you can put in them in the chat window or just unmute yourself and ask them.
Then I'll paste the repo here. All this is public.
Yeah, I'd love to try it out.
And then
You might want to paste that on Slack because the Zoom chat is going to disappear in a second.
yeah, I will.
Okay.
And then, oh, yeah, Mickey already got that. All right. All right. Well, I'll paste this all in Slack. Thank you all. Unless anyone has any more questions, and feel free to reach out. Ping me with a DM on SPIFFE SPIRE Slack, CNCF Slack, LinkedIn, Twitter, email, whatever. I'll get back to you.
Great. Thank you so much for presenting. So many integrations happening with SPIFFE and SPIRE. So